We will be distributing this afterwards. And Jay, Adam, you're more than welcome to use the recording as you see fit. But thank you everybody for attending. I know we had a lot of seminars this week, so appreciate everybody coming on Friday. We're going to go ahead and do a seminar on modular account. Spearbit did a review in the past. Gerard was one of the LSRs on the review, so he'll be helping comb through some of the findings and giving everybody some insight into those. We also have Jay, who's an engineering manager over at Alchemy, and Adam, who is a smart contract lead. But yeah, really looking forward to the presentation, guys. Jay, feel free to take it away.
Awesome. Thanks, Omar, for creating this opportunity for us to present on ERC-6900 and modular account. And thanks for the introduction. Yeah, we've had the pleasure of working with Gerard and team on not just one, but a couple of audits of 6900 and modular account as the standard evolved over time. Yeah, really excited to have Gerard share some of those findings and even some findings that helped shape this standard here. So before diving into the findings, I think it's helpful to just describe our motivations around ERC-6900, which is the modular smart contract account and plugin standard. We've been working with the community and folks at the Ethereum Foundation like Yoav to help shape this standard over time, along with some other smart contract teams in the space, like Circle and Decipher, who's a research group at Seoul National University. So we'll cover that and then go into sort of the standard overview and permissions model. And then Gerard will cover the modular account findings, and then I'll describe sort of the future of ERC-6900 and what we're thinking there. So with that, I'll hand it over to Adam to talk about ERC-6900.
Awesome. Thanks, Jay. Yeah, so diving into the sort of motivation behind modular accounts and the modular account standard. So account abstraction, big buzzword, lots of potential for improving the user experience and sort of just unlocking like what capabilities you can add to accounts with a sort of abstracted like transaction validation. So some of the ones that have been built and like we're experimenting on are like simplified signing flow with things like session keys, account recovery, other like security settings on your account. So this is things like multi-sigs or like virtual cold storage where certain things need a multi-sig, certain things don't. And a broader sort of class of actions around like automations. So things like dollar cost averaging or automatically like unwinding positions based on certain criteria. And just the sheer number of possible things you can build with account abstraction is so large that it's really infeasible for every possible feature to be built by one developer or for a single canonical account to support like every single use case that you could want out of account abstraction. So that raised the question of like, how can we securely grow the capabilities of an account in a way that's like incremental and on like a per user basis? And the answer to that is a modular account framework. So this is taking multiple accounts and having them manage relationships to other contract plugins. Some other like frameworks call these like modules. And essentially these package pieces of account logic into different functions. So you have like validation functions that affect the validation workflow, execution functions that happen, that define how the execution post-validation works, and then hooks that sequentially like attach to before or after certain action in the account. Yeah, and then on the standard side, outside of the framework, the reason a standard is useful is that it accelerates the development speed, lets you sort of pick up on work that other people have been doing. It can facilitate interoperability. So different vendors have different implementations of various either plugins or base accounts with making different choices. And you can pick and choose between them for which one to use. And the last one's like this reduced fragmentation. As sort of these things diverge, like a standard helps unify them back together. Yeah, next slide. And so I think the thing that really sets the standard apart and what's what we found like critical in the design of modular accounts is a well-defined permissions model. And this the diagram there is basically like describing the concept of like defense in depth, but essentially it's like the don't trust but verify. So allowing plugins to define explicit access to what types of resources they want, whether that's just permission for the account to interact with specific external contracts, interact with any external contracts, or do like access account resources like updating the owners, or hypothetically like installing or uninstalling other plugins. And defining this permissions model both for the plugins to declare and request and for the accounts to enforce lets us get this defense in depth and greater assurance about the correctness of the accounts that we're writing and using. And yeah, so diving a bit more into the specifics of the standard, standard defines these responsibilities for the two types of entities, being the accounts and the plugins mentioned earlier. On the account side, what this looks like is a known standardized execution flow. So essentially taking incoming calls, whether those are in the user op form or from regular just incoming calls, and performing this workflow of validation, pre-hooks, execution, post-hooks. Validation itself is also split up into multiple stages. So if an account wants to perform additional steps, those are also there are also pre-hooks on that. And these concepts line up with the validation phase and execution phase as they're defined in 4337. You can see in this diagram, this might be a bit small, but there's a sub box for the validation phase. But they're also intended to be backwards compatible with non-4337 workflows. So the similar type of workflow where if you have a safe transaction, you queue it up and you execute it from an EOA, those types of workflows can still be enabled by this standard. And the other aspects of the account behavior that this standard defines are implementing the plugin installation and uninstallation functions. So front ends can know how to like make requests about plugins to install. It also exposes standardized view functions for inspecting plugin state. So even a very sort of base account, you can see and like verify like what the execution flow will look like which plugins will be run by calling those view functions. And then the last measure is connecting back to the idea of defense in depth, but actually enforcing these plugin access control over the account resources. So that's validating that when the plugins are making either external calls to other contracts to interact with, or attempted calls to like account resources, that the plugins like do in fact have those permissions to perform those actions. Yep, and then on the plugin responsibility side, basically this is just them standardizing the format by which they declare how they can interact with the account. So the declaration step sort of happens in this big struct called the plugin manifest, and this lists all the functions they wish to install on the accounts. So that covers validation functions, execution functions, and hooks. And this is consumed by the account contract during the install step. Also in the manifest are the permission requests. So that's declaring the account resources they wish to access, whether that's calling a specific function like transfer ownership, or performing external calls on behalf of the accounts. The last point I wanted to make about plugin responsibilities is more of just a plugin implementer quirk, but if there's storage that a plugin wishes to access during validation, a common use case would be like loading in current owner from storage before performing the like EC recover in the validation phase. The location of the owner slot in storage has to be in address associated storage, and that's defined by 4337 and essentially can be thought of as a mapping from account address to the struct you're trying to deal with. It gets a bit more complicated with larger structs or nested mappings, but in general, it is something you can solve on the plugin dev side. And yeah, so as I described earlier on the responsibilities for plugins, the plugins report a manifest, and this serves as the coordination mechanism between the plugins, the account, and the front ends. So on-chain, the pieces within the manifest are used for the install flow. So the list of functions used for installation so that the account steps through and adds each of those. And this helps remove ambiguity of the install flow. I think in previous designs without the manifest, you sort of had to know the source code of the plugin that you're installing, at which point it doesn't really, you get various install states, and the overall developer experience is much more difficult. It also installs the set of permissions for either account resources or external calls, and the account is responsible for enforcing that. And the last important detail is there's a bit of front-running protection via manifest hashes. Because the manifest is a large document, it's unwieldy to put into call data. So instead it's loaded from the plugins themselves during execution. But then there'd be a risk of different manifest contents in between an ETH call simulation versus on-chain. And so there's a mechanism to protect against that. And then finally, off-chain, these function lists from the manifest help auto-populate SDKs with the plugin capabilities. After plugins installed, what are the new features and functions that can be called on the accounts? That can be automatically read from the plugin manifest, and or either TypeScript or for front ends, or if you're writing a backend, whatever backend language you want to choose, can auto-generate those bindings and help you perform those calls. And also importantly, the permission list is standardized and visible, so end users can see what the sort of blast radius is of a plugin before they install it. And the security of that blast radius is not something that's just the plugin self-reporting, but it is actually enforced by the base account.
Cool. Thanks, Adam. Next, we'll transition into sort of talking about the findings that came out of our security reviews for Modular Account. So, Gerard, I'll leave it to you.
Okay, yeah. So we did a few security reviews. So we were with myself, Riley Holterhouse, BlockDev, and Crystals. And first we prepared, of course, by studying ERC-6900 and also looking at other smart account implementations to have some background information and to be able to compare stuff. And when we did the first review, we found relatively a large amount of bugs, which were mainly due to the architecture being a little bit too complex, and because there were multiple ways to do the same thing. So that led to, in my opinion, unnecessary bugs. So when discussing the report, we suggested several things to make things less complicated. So, for example, one of the suggestions was that for the validation functions and the hooks previously, they could be any kind of function. So you could completely have different names for those functions. But all plugins need these validation functions and these hooks. So the idea was, why not just give them a fixed name, and then it's a lot easier to understand what's going on. The manifests are a lot easier, and that kind of thing. So then the team, the Alchemy team, did quite some redesign and simplification, which made the audits after that a lot easier, and we also could go a bit deeper on the reviews. So that was very nice. Next slide, please. Yeah, now we have a couple of issues that we found in the last report, just to give an idea. One of the things which, all the how do you call that? The plugins are pretty powerful, and if you would have a bad plugin, it maybe would sort of make itself that it would always stay installed. And that you cannot install it. So sort of like a virus that would be embedded in your operating system, and you would have difficulty removing it. So the project has taken quite a lot of effort to be able to install that. But because the plugins are so powerful, there are still some ways that you still can prevent installation. So we flagged that risk. But the project finally decided, well, if you always are going to force the possibility to remove plugins, that has also risks. So this is one of the risks that is still remaining, and it also shows the importance that the plugins have to be audited. And we'll come back to that later in the next slides. Next slide. This was one of the interesting findings. So a plugin can expose functions to the smart contract, so that the smart contract has additional functions that can be called from the outside. And there was a small bug that a plugin could basically expose all functions, so also the internal functions from within the plugin, which should never be exposed to the outside. So that's we found that, and that's easily fixed by just filtering out those selectors, and so that's no longer an issue now. Next slide. Yeah, the smart contract has a possibility of session keys. So that's one of the plugins that's available, and that allows you, for example, if you have a game, then you can make some mechanism that you don't have to approve every little thing that you're doing in the game, but that you can give one external address, sort of an allowance to do a certain amount of things. And the code was such that it checked the transfers and the approves that were done by that external address, and we're tracking that and making sure that wasn't going over an approved limit. But while checking the code, we noticed that there are more ways to manipulate your tokens. So not only transfer and approve, but also the increase allowance and transfer from can also be used. And specific tokens like DAI, they have very weird functions that also allow you to move tokens. So checking transfer and approve wasn't sufficient. So that's solved now, that only transfer and approve are allowed, and all those other functions are disabled. So they made actually a sort of a whitelist that only those two functions can be allowed, and everything else is disabled. Next slide. Yeah, when you create a modular account, there are actually two ways. You can explicitly create one, or you can even create a counterfactual address. So you can calculate the address for such an account even before it's created, and you can already send tokens to that address. So then later on, when somebody creates the account, they already have some tokens. But when you create such an address, especially when you create an account later, there are some circumstances which are not allowed. So, for example, you have to supply a list of owners, but if you don't supply any owners, then it's of course difficult to do anything with the account. Or if the number of owners is super large, then you're going to run out of gas. And the creation of the counterfactual account didn't really check all those circumstances. So we suggested to also check that, just to prevent accidentally creating a counterfactual address that doesn't work. But it's in the end, there was still a risk left that if you would create an account with only invalid owners, then you still would brick your account basically, because you cannot do anything with that. But that's very difficult to check. So basically that risk is still there. But you have to do quite a lot of effort to create your own account with only invalid owners. So the risk is pretty low on that. Next slide. Yeah, so basically the conclusion is that the plugins are pretty powerful. You can do very interesting and nice things with it. But if you create a plugin, you have to be careful not to shoot yourself in the foot, because you have that many powerfuls, that much power. So you can reference other plugins and do stuff with other plugins. So that has to be checked pretty well. Plugins are shared by users, so you have to be careful that you're not going to mix data from different users. And you have to take care of the ERC-6900 requirements. So you have to do security reviews on the plugins. You cannot just let anybody create a plugin, because it's easy to create a malicious plugin. So that's why all those other stuff is there, also the manifest and the user interface, to prevent that and to detect that. Next slide. So the idea is that there's this base contract from the modular account, and there are plugins that are audited. And when you're going to deploy those contracts, you don't have to re-audit everything again. Only if you create a new plugin, then you have to basically review, audit that new plugin and make sure that it doesn't do any funky stuff with other plugins and with the account. You have to, of course, be aware of what other plugins are doing. So there, the project will create some sort of lists that you know which audited plugins there are. So when you're going to review that, so that might be anyone who's listening now in the future, you have to know those plugins, and of course the account contract and the ERC-4337 standard, and then you would be able to plug in that to review that plugin. Okay, this is my input.
Well, great. Thanks, Gerard. And that's a great point about sort of being able to know which plugins that are out there and audited. So since we're in the early stages of building out the 6900 ecosystem, sort of the start of that process will look like something maybe like a GitHub repo, where we keep track of a known and audited list of plugins. But going on from there, what the future could look like is we have an on-chain registry of plugins that are audited. So more thinking to do around that as the ecosystem evolves. But cool. So I'll talk a little bit about what we're thinking for the future of 6900. So a lot of our efforts right now are concentrated around sort of this simplification of the standard. And to just talk through some examples. So one place where we can simplify is in validation. So allowing better function reuse with multiple validation function support. So what does that mean? Right now, with the standard, we allow each sort of execution function that can be installed by the plugin to the account to be protected by a single validation function. That validation function could come from the plugin that is installing that execution function, or from other plugins. Generally, that'll come from an ownership plugin that is installed on the account during account creation. So right now, it's a little rigid in the fact that each of these functions that you install on the account, each of these capabilities that the account can perform, are protected by just a single way to validate that user operation. So we're exploring ways to be able to switch between different validation functions that different plugins might be able to provide to the account, such that an execution function on the account can be called by different validation mechanisms. So one example could be being able to call and get permission to call an execution function via, multi-sig, or via the traditional ECDSA signatures that we have right now with our multi-owner plugin, or via other mechanisms like P256 signatures. So I think expanding on the standard to allow for this switching, and that switching could be done in various ways, but we're thinking that sort of wrapping the call data to include which validation function to use on a per call basis seems like a good start. So we're exploring this effort. Next, manifest simplification. So dependencies can be error prone, so how can we provide flexibility safely? So to talk a little bit more in detail about what this means is right now, plugins can depend on other plugins. So for example, when you're installing, let's say, a session key plugin, for instance, the ability to add new session keys to the account is going to be protected by the validation function from an original ownership plugin that's installed on the account itself. So how the session key plugin describes this relationship is within its plugin manifest that Adam had talked about before. The plugin manifest declares that it requires this dependency to be passed in as part of the call data for install plugin. And it also requires that plugin to be installed on the account. And how it specifies that is via interface IDs, which can be a little bit brittle. So with the introduction of the fixed names for validation functions and hooks that Gerard described earlier, the interfaces of plugins can look pretty similar across different plugins. And if two plugins, they just offer, for example, validation functions and hooks, without sort of these execution functions that are installed in the account via custom sort of function names, interface IDs can look identical. And also with the idea of sort of being able to use sort of different types of plugins for validation, especially sort of going hand in hand with the validation simplification proposal that I talked about earlier. It would be nice to sort of think about a more flexible way to do this, and a more less error prone way to provide these dependencies. Next, so hooks can get expensive. Can we achieve similar composability elsewhere? So we've started sort of making strides on this already with sort of a hook simplification proposal that came out of some findings. So with that, previously in a prior version of ERC-6900, hooks were also allowed to be provided as dependencies as part of the install plugin process. But we've since sort of simplified the standard to take that out to cover up some, protect against any security issues that might result, that might come out as a result of being able to have hook dependencies. Also, layering hooks on top of execution functions can get pretty expensive during sort of the execution phase of trying to load all those hooks all at once. So is there a way to maybe pack that data into storage in a more efficient way and sort of be able to compose things in that way? So thinking more about that. Another thing is around sort of default ownership. Right now, when we're creating a modular account, it requires an ownership plugin to be installed as part of sort of that initial account creation user operation. And that plugin that you install first is responsible for adding in all the validation functions to the native functions on the account, as well as any other functions that that ownership plugin installs on the account. What this means is an increased sort of execution cost during account creation, but also there are sort of risks to be aware of here, in that if you accidentally uninstall the ownership plugin that exists on the account without sort of batching that same without sort of batching an installation of another ownership plugin within that same operation, the account could get bricked. So this is an idea that would sort of address both of those issues of efficiency and removing sort of foot guns in terms of being able to brick an account. So that's an idea that we're also exploring. So we're doing this all out in the open. You can find some these issues and more that we're thinking through with the community on the ERC-6900 resources repo linked right here. So feel free to check that out. And next, 6900 will evolve with sort of account abstraction evolving over time. So we have exciting updates like recently 4.3v7 version 0.7 went live, and that introduces changes to the user operation struct, as well as introducing a new function for accounts called execute user op, so that you'll be able to have more context around the user operation during the execution phase. And we have native account abstraction being supported in rollups with RIP 7560. And what that means is these rollups will implement the ideas from 4.3v7 natively to reduce gas costs, sort of like fixed overhead costs in terms of crafting a transaction that looks like a user operation, as well as introducing different interfaces for validating these new transaction types. So instead of validate user op, we have, I believe, what's called validate transaction with different parameters. So with these upcoming changes, thinking more about like what makes sense to enshrine into 6900 versus abstract away, potentially abstracting away these validation mechanisms into plugins or some other approaches that we're thinking of. And lastly, thinking around the evolution of how front ends and clients can interact with 6900 accounts and plugins in a consistent and secure way. So here we have screenshots of what the plugin manifest struct looks like, and also a plugin metadata struct that a plugin can implement to reveal metadata that's not associated with the installation process. So things like the name of the plugin, version author, and also permission descriptors. And these permission descriptors are helpful sort of human readable strings that the user can see when they're installing a plugin to see what sort of permissions a plugin is requesting at installation time. So there's a lot of work to be done here to make sure that all of the relevant permissions and sort of capabilities that a plugin is adding to the account is surfaced in a consistent way across different dApps, across different user interfaces, through it could be standard SDKs or sort of more standardized efforts in that space. And we've done a lot of thinking around how to provide these permissions and informations about plugins installed on accounts through things like the account loop interface that is also part of the standard. But more thinking and work to be done here to get ecosystem alignment on how front ends and clients interact with 6900 plugins and accounts. So that's the end of things. I have some resources here. So we actually launched our modular account 2 days ago, along with the audit, the security review report from Spearbit. So feel free to check those out. And I've linked the ERC as well as the ERC-6900 repo with some resources and the reference implementation. So that's it. Thanks everyone for taking the time to listen in and learn about 1600 and the findings and things to be aware of when building this ecosystem.
Excellent. Yeah, thank you guys so much. This is incredibly informational. I think, let me just double check and see if we have any questions, folks. If you have anything, you can go ahead and just drop a comment in the local chat. So Jay, Adam, you can see questions, they'll populate. If you, on the channel that you're in right now, it's Spearbit 2, on the top right, there will be a small chat button that should have any conversation if anybody has anything. But yeah, so far it doesn't look like we have anything. It seems like it was fairly straightforward, but we'll give it like 30 seconds or so. If anybody has any questions, we'll give you some time to type. If not, then we'll go ahead and conclude. So,
great, sounds good.
Going once, going twice. Okay, cool. Looks like nobody's typing. But yeah, thank you guys so much. This is a fantastic seminar. This will be recorded. And yeah, thanks everybody for attending. Appreciate your time. Jay, Adam, Gerard, if you guys want to say anything to close out, floor is all yours.
Thank you all for listening, and yeah, happy to answer any questions you have at other times about Modular Account, 6900, or Alchemy's work specifically in this space. So thank you all.
Perfect. Take care, guys.
Yeah, thank you, everyone.
Bye.
Thank you, everyone.
Thanks. Bye.